Hi and welcome to challenge number 18, flatten nested arrays. In this challenge, our task is to flatten a deeply nested array to a single level. And what I mean by this is, take a look at this array. So this array, it has this bigger outer array. It has three items. It has a number right here. It has something that looks like another array. Yes, it is another array. And then it has another number here. So three items. The array inside of here, this is a nested array, but one level deep. But then this array, it has another nested array inside of it as well. So you can see we actually have three arrays. Two of them are nested. Our task is to change this into this. So it doesn't matter if we have one array inside of one array that is nested, or we have 10 arrays that are nested, or 1,000. We need to flatten. Flatten basically means we get rid of all of their square brackets and we grab all of their elements out and put it inside of the big mother array. So that's basically our task. The first language is, of course, as usual, JavaScript. And doing this in JavaScript is extremely simple. The first thing that I'm going to do is I'm going to create a function. You can call this function whatever you want. I'm just going to call it flatten array. And what this function accepts is going to be an array. Now, we just talk about an array of numbers. In JavaScript and sort of TypeScript, we could come up with some way of actually having multiple items, multiple data types as items for our arrays. But in languages, lower level languages like Rust, that's a little bit more tricky to implement. And since I've already implemented those in like challenges 11, 12, 13, you can implement this challenge in Rust and go for data types other than numbers as well. But I'm just going to go ahead and I'm going to stick to numbers. So the JavaScript solution involves a built-in method. And if we select this array on the array, we have a built-in method that is called flat. That is going to flatten the array for us. So what this flat method does is it's going to create a new array and it's going to select all these sub-array elements and it's going to concatenate it into to this array, or basically just copy paste all of the items in here without their nested arrays. Now, this requires a keyword. You need to specify how many levels you want to go deep. Now, our input, it could have 10 arrays as nested arrays. It could have 100. It could have 1. So we have a variable number. And for that reason, I'm just going to pass an infinity. So what infinity does is if we have 2 levels, 10 levels, or 1,000 levels, it's going to work. And then that's what we return from this function as well. Now, I don't want to actually type these out. We have our input, which is the same thing that we had here inside of this challenge. So we have 3 arrays, 2 of which are nested, which we want to actually get rid of. And I'm going to give you these 2 console logs as well. That's going to show the input and the output. Let's save this. Let's run this. This is going to be node a tab. Let's hit enter and there we go. So our input array is nested 2 levels deep, but our output array is very interesting. It just has some elements, 1, 2, 6. It doesn't have any trace of any nested elements. Now, I want to show you, basically I want to give you more examples as well. Not to type these out, they are going to take a long time for me. The first one is a very simple array. This one right here, this is basically the second one. The other one, it is 1, 2, 3, 4 levels deep. This one is actually 10 levels deep. This is an empty array, and then we have an array that has an item, an empty array, and then we have an empty array in here as well. So a combination of like different possibilities. Save this. Let's run this again. So I'm going to clear this and I'm going to run that again. And there we go. It doesn't matter how we go about this. The output is going to be expected. So we have 1, 2, 3 for the second one. Then we have this one. We have our 10, even though this is 10 levels deep, we just have one array with 10 items inside of it. We have our empty array, and then we have the 1, 2, 3 array, which is the last one. Because these arrays are empty, if we get rid of them, it's not going to do anything. It's just going to produce like an empty space there. Cool. So this is it for the challenge for the JavaScript solution. Let's jump in and let's talk about TypeScript. Now, in TypeScript, this is a little bit tricky to implement because whenever we talk about array items in TypeScript, we need to type annotate them. So the array item could be of type number like this. So let's say this is our array. I'm going to say let our input array, or input array, not our input array. The type of this could be number, an array of numbers, and then this could be whatever you want. Now, this could be an array of numbers. It could be another array like this, and then this type. You can see it is throwing some errors here for us. Now, it's variable. It's going to be different depending on what type of the item it is. One solution for this is, so let me just explain that better. In here, we just have an array of numbers. That's easy. In here, we have an array of an array of an array of an array of number, right? So 4 times. But in here, we have 10 arrays inside of it. So we need to type annotate that 10 times with this array. So this syntax has to be repeated 10 times. In here, we just repeat it once. And in here, you can see it's variable. We repeat it once, twice, and thrice. So this makes it difficult to type annotate our input array. One solution for this is to use the any type. And for this specific challenge, our TypeScript is going to have 2 different solutions. The solution's difference is just in the way we type annotate our input array. And I wanted to show you both of them so you really know, okay, this is one use case. You can use the any type. And that would basically mean you could pass in undefined, you could pass in null, which we are going to filter out, but you could pass in. And then you could pass in strings or booleans as well. And now, if we were to go with any, how would we go about this? Well, since this is the TypeScript solution, we're going to go as manual as possible. So we want to replace all of the built-in methods with their manual counterparts. Now, I'm going to call this flatten array type 1 because we're going to talk about type 2 as well. Or I could just call it flatten array, and then I could comment out the parts where they're different so you can have both of them inside of the same function. We have this array that is going to have a type of any for now, right? You know what? I'm just going to call this type 1, right? That's better. So the input array could have any type. That means it could have an array, one array as nested element. It could have 2 arrays as nested elements. It could have 1,000 arrays as nested elements. The type is any. The first thing we need to do is, since we want to create a new array, we need to create a new variable that's going to hold that new array for us. But the type of this array is also different because we don't actually know what kind of an item we're going to get inside of here, right? I could type annotate it as number because this result is going to contain our numbers. But you could type annotate it as any as well. Since you might pass in strings to this, you are going to say, okay, this has a type of any, and then I'm going to pass in strings. But the problem with this is that since we are actually returning this result, you can see the type of result is different than this any that I've specified here. But I could change that. I could argue, okay, that what the function produces is going to be an array of numbers. So I can just pass that in there. Very good, much better. Now we just have any in one place. Let's go ahead and here I'm going to create a new array, and that array is going to be called our stack. So this is going to be a stack data structure because we need to have an intermediary stop in order to process our elements. And I'm going to talk about why this is important once we actually start processing our elements. I'm going to call this stack so you really know what this is. and this is going to have a type of number as items. This could end up with any, so let's just pass any here for now. Now, the job of this stack is to select one item from our array and reverse that and put it right here. Because the way stacks work, they work based on the LIFO data structure. So last in, first out. The reason that we do this is because we don't want to use some sort of a built-in method that is like pop or push. So that's why we use this. And as I move along, you're going to really understand why this is important. So the intermediary step for us is to iterate over all of the items inside of the array, the input array, and populate our stack with that in the reverse order. Because we want, if an array contains numbers 1 to 6, 1, 2, 3, 4, 5, 6, the output array should contain the same thing. If we don't go with stack, the output array is going to have the reverse of that, because we're going manual with this. And let's actually create our loop agent. This is going to be I. Now, since we want to start from the other end of our input array, we're going to say array.length. Now here, I is not going to be equal to 0. We're going to say, okay, you need to start from the other end of the array. And how do we select the last element inside of an array? In TypeScript, we just say length minus 1. That's going to give us the last item's index, because length is always 1 greater than the index of the elements. So if the length is 5, the last item's index is 4. So we say start from 4, that's 5 minus 1, length minus 1. And how long do we want this to go? As long as I is equal to 0, that basically means we have ended at the very first index. So we start from the back, we move our way, we move through the array to the start. And the start of the array has an item that has an index of 0. And since we move backwards, we're going to go with I minus minus. We decrease the index by 1 in each iteration. Now, depending on what we select inside of the input array, so inside of the input array, we select one item. The first iteration is going to be the last item, and we want to put it inside of our stack. So how do we put it inside of the stack? We're going to select our stack. Now, if you want to put an item inside of an array, stack is an array in this scenario, right? You need to specify which position that item should occupy. Now, we want this item to occupy the first position inside of our stack. And we can go two ways with this. We could create another variable that is going to keep track of this state for us. The state which specifies where we add another item, that index, that position. Or we could do this with the length of the stack. So initially, think about this. Initially, the length of the stack is 0, right? What is 0? If you convert it to an index, 0, if you say length is 0, index 0 is the first position. So in this scenario, I can just say wherever the length of the stack is, that can be our index where we populate or where we add a new item. So that's the first iteration, right? In the second iteration, we select another item. It doesn't matter what item we select. That doesn't matter, the actual item. Now, we want to put it inside of the stack. Now, the stack has now one item inside of it. So the length of the stack is going to be 1. And if I say index 1, has index 1 been occupied? No. So we added at the index of 1. Now, in this scenario, we don't subtract the -1 from the length because we don't want to select the last item. We have already selected that here. So if you want to select the last item from an array, you just subtract the length by 1 and you're going to get that item's index. But here we use the length to populate the stack, and length is a very good way. So we use it as a substitute for our index. We say length 0, that means index 0, that means the first item. In the second iteration, length is already 1. So length 1, index 1, that means the second position. Cool. Second iteration, second position, third iteration, third position. So I can just very well say, as I stated that before, you can create a new variable, initialize it to 0. I've actually done that in these exercises, in exercises 11 to so far 18. But I want to show you, you can do this as well without creating some overhead, extra overhead for yourself. So you create another variable, you initialize it to 0, and then after each iteration, you're going to say that variable plus plus. You increase the count of that. Or you could select this length, which is already there. So effectively, so far what we've done is we have selected the items and we have put them in the reverse order inside of this stack. What we need to do next is we need to actually select these items from our stack and put it inside of the result. And for that, I'm going to use a while loop. So I'm going to say as long as the stack's length is greater than 0, that means there is something inside of the stack. So if our input array is empty, stack is going to be empty. There is nothing to show there, right? So as long as there is something inside of the stack, we want to grab the last item of the stack and add it as the first item of the result. So what do I mean by this? Let me select our JavaScript. I should keep this open. So here is our input, right? This is the input. You know what? It's all the same. So I'm just going to select all of them, put them right here. So in our very first input, let me copy that, just put it right here. In the very first input, we have 1, and then 2, 3, 4, 5, and then 6. So stack, what stack actually includes is after each iteration, it's going to include from the behind, from the back, right? So it's going to include 6. It's going to get rid of this square bracket. It's going to pop 5 for us. And then it's going to pop 4, 3, 2, 1. So I can say effectively, this stack includes the following items. Let me just pass it there, but they're going to be in the reverse order. Well, I could have just typed that. 6, 5, 4, 3, 2, and then 1. So stack contains all of these items at this point. What I want to do is, now you can see the order of this is different than this order. We just need to have to select the item from the other end. So we select the last item of the stack, which is 1, and we put it as the first item of the result. And that's it. How do we do this? We can use a while loop in order to do this. So we're going to say const the current item. The current item is the last item of the stack. How do you select the last item from a stack? You're going to say stack.length -1. You already know that. So what is in the first iteration, what is the last item of the stack? It's 1, all right? It's 1. What do I do with that? Well, I need to check what that is, right? Is that a number? Is that null? Is that undefined? Is that an array? What is that? Well, I need to do all of these checks. And now before moving forward, we need to actually specify how can we select the other items here. Let me just zoom this in so it's really visible. I'm going to provide some spaces here. And there we go. So in the first iteration of this while loop, we selected number 1. We know how we selected that. We said stack length -1. That's going to select the last item for us, right? So if length is 6, -1 gives us 5, which is the index of this element, right? We select items by indices. We don't select them by length. You need to keep that in mind. We select array items by indices. Length gives us a very good indication of how many indices there are. Cool. So in the next iteration, we want to select this. So if length is 6, I say 6 -1, that gives me 5, and that gives me the last item. Cool. If I say length is 5, keep in mind, length is 5, and then I say 5 -1, that's going to give me 4, which is the index of this, right? Again, when length is 4, I say 4 minus 1, that's going to give me 3. 3 is the index of this element. Cool, cool. Length is 3. I say 3 minus 1, that's 2. 2 is the index of this element. So in this scenario, as I keep subtracting the length by minus 1, I keep moving through the array, but from the other way around, in reverse, right? So I move in reverse. So if you say 0, 1, 2, 3, 4, 5, that's moving forward. But if you say you say like this is 5, 4, 3, 2, 1, and then 0, that's moving backwards. So since we populated this backwards, we're going to move backwards because the last item, 1, is the first item that we want to select, right? LIFO, last in, first out. That's why we're using a stack. So now you see why stack is very important. In this stack data structure is very important for us in here. So the last item is going to be the first item that we select. So we say stack, and we keep decreasing the length by 1. So the stack's length is going to be stack.length minus 1. And that's going to give us a decreasing number of indices. In this scenario, we move to the front. I hope you have understood this. I tried to explain it in so much detail that took up so much time. Now that we know we are moving backwards, but through the length of the array, we need to select one item and take a look at what that is. So I'm going to say const is array because that's what I'm actually interested in. If the item is an array, I want to flatten that. If it is not an array, I just put it inside of the result. What do I mean? So if the item is 1, what do I do with 1? I just copy 1 and I put it inside of the result array. But if the item is this array, I need to flatten that, right? How do I know that? What item have I selected? So I'm going to select my current, and I'm going to say, as long as current, as I told you, we're going to filter out null and undefined. If current is not null, and if current is not undefined, what else? Now, how do you specify an array? Well, in JavaScript, an array is an object, the keys of which are actually numbers, right? So an array, you might know this already, an array in JavaScript is actually an object. So it does have keys and values. The keys are its indices. It's 0, 1, 2, 3, 4. The values are the array items. So if the type of current is equal to an object, that's okay, this is an object. But if the keys of it are the keys of the object, they are of type number. We need to specify that as well. But before specifying it, we need to actually say that this array has a length and then it has some keys as well. So I'm going to say if length object, and if the length, let me just add another. Come on, buddy. There we go. If length inside of our current, which is an array, has a length, and the length type is of array, so type of length, should be together, type of length, which basically means our keys, is equal to the array. Well, this is not how you write it. You're going to say current.length is equal to number, then this is our array. I added an extra ampersand, and there we go. So what is this? We basically filter out all the nulls from here, and then we filter out all the undefineds. We specifically say if the type of current is an object, and if we check that there is a length inside of this current, you know indices depend on the length, right? That's why I say the type of the length or the keys are number, right? Because indices are something that we derive from our length. If the length is 0, the index is 0. We don't have anything. The index is not even 0 because there is nothing inside of there. The index could be null or undefined. But as long as we have a length, then we have an index. So indices depend on the length, right? So if this is true, that means we have an array, right? What do we do with that array? We need to expand it further, right? How do we flatten that further? Well, we basically repeat what we did here. What did we do here? We selected that array, right? And we converted that to a stack in reverse. So we do the same thing in here. Again, this is for the nested array. So if you pass in an array that has items 1, 2, 3, this part is not going to be implemented. You're just going to put all the items 3, 2, 1 inside of the stack, and then you're going to do this line, not this line, and then we're going to do an if statement to actually check this, right? So instead of just copy pasting that there, I need to provide my if statement. I'm going to say if array is true, that means there is a nested array inside of our array. We put it inside of our stack. We expand it further and we put it inside of the stack. But here we're not talking about the input array. We talk about the current, which is an array, right? So I'm just going to pass that there. I'm going to pass that there. So I hope this is not confusing, because let me just show it to you, because we checked this type of the current. In this scenario, in the first iteration of the while loop, 1 is not an array, it's a number. But in the second iteration, this is an array, right? So this if statement is going to hold true. And what do we do with this array? We basically put it in reverse inside of our stack. We put it 5, and then 3, 4, and then 2. Cool. In the third iteration of this while loop, we select 6 and we put it inside of our result, right? So in the third iteration, we put 6, but before going to the 6, you can see here we have another nested array. So once we checked 2, put it inside of the stack, we see that current is going to be an array right here. And then we do this if statement again for that nested array. So this is a while loop. As long as the condition is true, it's going to keep running. So if there are 1,000 or 1,000,000 nested arrays, it's going to keep working through, and it's going to keep flattening the inside arrays, the arrays inside of the big mother array. And you can see all of this, just to avoid using this array.flat. And you can see how crucial these built-in methods are and how difficult it can get if you want to implement them manually. You need to think about a lot of things here. So this is for the condition. The if part is for the condition if our current element inside of the big mother element is an array. But what if it's a number like 1 and 6? Well, we don't do anything, as I stated earlier. We just select our result and we put it in there. Result.length, we do the same trick, and we said, okay, that's going to be our current item. Now, you might be worried that we're going to put 1 and then we're going to leave this to evaluate, and then we're going to put 6, and that's going to distort the order of the input array as well. No, we're not going to do that. So we do 1, that's going to be our current element. Let's go step by step with this. So our current element, our current is 1 in the first iteration, right? So when this is 1, we say that, does 1 satisfy this? No, it doesn't. 1 is not null, 1 is not undefined, 1 is not an object, it doesn't have a length, and the length is not of type number. So this is false. When this is false, we don't go inside of this if statement, we go inside of the else. We select that 1 and we put it inside of the result. Now keep in mind, we're not talking about the input array, we're talking about our stack, because we're iterating over our stack. The comment that I've written here, that's the final result of the stack, not the process. As I told you, we need an intermediary stop to process all of these elements inside and put them inside of the stack in order to put them inside of the result, in order to later copy them. So the first iteration, we selected 1. In the second iteration, we don't have 2. We have this array that has an item 2, another array, and then an item 5. So we select 2, right? We put it inside of the result, right? So this condition is going to hold true. And once this condition holds true, we select 2 from here and we put it inside of the result. But before moving on to this array, we need to make sure that this condition holds true in order to flatten this. So we select 3 and 4, we put it inside of our stack, and then we select 5, we put it inside of the stack, we select 6, put it inside of the stack. So by the time you get to this else statement, all of the items will have been flattened, and you just select the flattened items and you put it inside of the result. That's it. That's very simple. Now, the final thing that we need to do is we need to return something from this function, and that is going to be our result. So return result, and that's it. Let me run this. Clear TSC, B tab, enter. Clear this node, B tab, hit enter. Okay, we seem to have inputs. This is our input. The output is actually empty. So let's take a look at this. If array for, we have our stack. I could log our stack, right? So, and I could log our result. Here, this has to be a result. Save this. Let me bring this up. Clear this out, first TSC and then node. Okay, so we can see our stack is empty as well as our result. I could pass in result here so we know what our result is. Close this. I could pass in stack here. That's our stack. So we said we want to select the last item of the array, right? And we recursively put it inside of the stack itself. And then we make sure to go backwards by doing I minus minus. So this, the result is empty. I know why the result is empty, because the stack is empty. So the problem is inside of this for loop. The stack has to have something inside of it, right? If this for loop is fixed, that means we have basically gotten rid of this issue. So here, this is our variable. This is our condition. And then, yeah, I feel like I know what this problem is. So the problem with this is this condition. This is actually, in my opinion, a very good thing. This is a very good learning point. So for that reason, I'm just really zooming this in. So if you take a look at the anatomy for a for loop, it has a few things. The first thing that it has is this for. The second thing is this part where you have the for loop expression, the part where you have parentheses. And then you have the block that's going to run depending on how many times you specify it. Inside of the expression, inside of these parentheses, you have the initialization of the agent of the for loop. You have your condition, and then you have the either increment or decrement operator, right? So the problem with this for loop is its condition. As long as the condition is okay, the loop is going to run. Now the loop is not running because the condition is actually incorrect. So we say, as long as the condition holds true, the for loop is going to run. That's the mechanism that makes sure the for loop runs. So our condition says start from the length of the array minus 1. Okay, so that's 5. In our input array, the length is actually 3. We have 2 items in a nested array, but the length is 3. 3 minus 1, that's 2. So I is going to be 2. I is not equal to 0, right? And then we say we decrement I by 1 after each iteration. We say here iterate through the input array as long as I is equal to 0. Here, I is equal to 2. Is 2 equal to 0? No. Keep in mind, this is not our condition. This is our condition. So our condition is 2 equal to 0. Is that the same? No. Therefore, it's not going to run because the condition is actually false. So what we could do is we could specify iterate over this iterate over the input array for as long as I is greater than 0. Well, that's going to be, there are two problems with this. You could end up with an infinite loop, or you could end up with a loop that does not select the first item of the array. What do I mean? So if you say I is greater than 0, I'm not going to save this and I'm not going to run this. So if I is greater than 0, you know that the first item inside of an array has an index of 0, and you need to select that. If you say I is greater than 0, it's never going to select that 0. So we're going to say as long as I is greater or equal to 0, right? And now you can see the parentheses are gone, and now we can run this. So let's clear this out, compile this, and then run it, and there we go. It's very cool, right? So let's take a look at this. We have a result in the first iteration, which is empty. We have the stack, which is empty. And you can see the input is this. But from here, we just select inside of the output 1 and 6. Why? Because we have made a mistake and we need to fix that. We did not flatten the nested array, right? And why didn't we do that? Because when I changed this condition, I needed to change the condition here as well. Because the first for loop for our stack is responsible for the first inner items if they're not numbers. If they're nested arrays, this for loop is responsible for flattening them. So now if I save this, come right here, clear this out, and run this again, there we go. We get the result that we're looking for. Okay, very good. So our stack and our results are empty because they are at the start. At the start, stack is empty and result is empty. So if I just select them from here, just cut them, put them before the return, here is where we have populated our stack, right? So clear this out, run this, and then this. Very good. Very good. So here you can see this is the result. This is our result, 1, 2, 3, 4, 5, 6. Our stack is empty. The reason that the stack is empty because we have actually popped out all of the inputs from the stack. The stack is not going to have anything inside of it, but our result is actually working perfectly fine. So here is the result for this one, and then we have this result for this one, and you can see it's working perfectly fine. Now, if you want to take a look at the items for your stack, you need to select this and you need to put it right here. Whenever you have, or at the end, let me put it there. So let's save this. Let's see. We should be able to see something inside of the stack. And there we go. We have a lot of things, and this makes my point. This is very good, right? So we have our stack, right? We have a lot of arrays here because these are for the items in each iteration. So you can see we start from 3, and then 3, 4, 2, 4, 5, 3, 6, 7. So this is how the stack works. It's a little bit confusing. In the last iteration, we have 10, we have 9 and 10, then we have 8. Since 10 is inside of another array, if you take a look at this, so this is, I know which one that belongs to. You can see it talks about this one. 10 is the basically the deepest level or the deepest nested array inside of this big mother array. That's why it shows it like that. And that's why it's the last item in the last iteration of our stack. but the result is expected. We have our perfect result. So what I'm going to do is I'm going to get rid of these console logs. You can manipulate this, you can work with this, but this is one of the ways that you can actually implement flattening arrays inside of TypeScript, but going as manual as possible. Now, there is one more thing that I want to talk about before wrapping this solution up. We did really dive into a lot of details here. And what I want to talk about is this type 1. I told you that you could use the any type or you could use some other type. There is another way, but the first thing that I want to do is I want to test if a number type, it shouldn't work because the stack at this point, you know what, let's save this. You can see if it is of type never. There we go. Yeah, type number doesn't work because our stack could have nested items, and this if statement is responsible for flattening the nested items. Now that that part is clear, let's talk about how can we convert this any to a type that is not so unsafe for us. So the way we can actually convert this to a type, another type is I'm going to copy this entire function, comment this one out. I'm going to come right beneath it because I want you to have that as a reference. This is going to be selecting all of these. That's going to be flatten array type 2. So one solution for this one is actually a recursive type. I haven't talked about recursive types. The way recursive works in this specific scenario is we say the type of the inner items inside of the array, they are of type X. Let's say type X, right? They're of type X, or let me comment this one out, or an array of type X, right? Or an array of type X, but then that's going to be involved inside of another array, so a nested array, or an array of an array of an array. So you can see it's 3 levels deep, right, up until now. Or I'm just going to give you one more, or an array of an array of an array, right? So here I need to have another one. So now this is 4 levels deep. Now, what recursive is here in simple terms is we just have this X, and then this is the actual type, right, that we use here. We have the X, we put it inside, and then it goes after each iteration, it could go 1 level deep. And the number of levels that it could go as deep is not specified. It could be like 10 nested arrays or 1000 nested arrays. So what we need to do is we need to peel this onion, like peel by peel, step by step, layer by layer. And that's recursive. So you do it once and you select that logic, you do it again. That means you have targeted one nested level. You select that nested level, you repeat it again. That means you have targeted the second nested level. And then you select the second nested level, you repeat that. That means you have targeted the third nested level. You might be asking, okay, isn't that the same thing what we do inside of a for loop? No, that's not. Yes, it is, and no, it's not. The reason that it's not is a for loop is actually moving through the array, right? It's not going inside of a nested item inside of the array. It's selecting that thing. So if you say I is 1, I is 0, the length of the array is 10, and the array has 5 nested items inside of it, it just selects those nested items. It doesn't go inside of those nested items because you select one thing and you repeat the same thing. But in recursion, you select something, you transform it, and then you repeat that transformation. And then once you have transformed it once, that's the first transformation, like here. So we selected this, we transformed it to go inside of the first array, right? So we repeated the transformation again. And then here we repeat that transformation again. We repeat that here again. And in after each step, you go one level deeper. So that's the way recursion works in this specific scenario. I try to explain it as simply as possible. So that's the type that we are going to create. We want to create a type that is of type X or a recursive of the X, right? What is the X? The X is a number. Now, we say it could be X or, so we use a union type in TypeScript, or a nested X. So instead of just saying X, one level deep, and then 2 levels deep, 3 levels deep, we could just say nested, right? So I'm going to say nested number. Now, if it is nested, it is an array, right? Because if you just have 10 items, 1 to 10, number 1 to number 10 inside of the array, they're not nested. They're just, all of them are right in there. And there is no need to flatten that. We just flatten the nested items. So therefore, we're going to say nested number, you could number array. Now, this is an array, right? So I'm just going to say array. The cool part comes before. It's not after the equality sign, like on the right hand side of the equality sign. The cool part is what is on the left hand side of this equality sign. Now, since this is a type, I'm going to specify as a type. I'm not going to use an interface because we don't talk about objects here, right? Interfaces work for objects that have curly braces, not square brackets. So the important thing is, what should I call this? That's the important part. So I said X or a nested X, and then nested X, and then nested. So in each time I'm nesting the X. That means each time I'm using this nested array. And there we go. This is your nested type. Or you could call it, this is a recursive type that represents an array that can be nested to any depth. So if it is not nested, you're going to say, okay, the array has items 1, 2, 3. For example, this example, the second one, it doesn't have any nested array inside of it, right? So it just has 1, 2, 3. So for that scenario, the nested number array type is going to be number. That's it. But if you go one level deep, you still have a type of number, but an array of that, right? If you go 2 levels deep, you have a nested numbers array, but then you nest that again. As I said, you transform something, but then in the next iteration, you select your transformation, you transform that again, and then you get something else. And you keep doing this. But in a for loop, you don't select your transformed item to transform it again. You select a completely new item. So that's the difference in this specific scenario between recursion and for loop. Both of them move throughout the type or throughout that specific data structure, but in different ways. And I believe this example specifies, clearly indicates how recursion is going to work. So you have X, right? So X is the same here, here, and then in both places here. We have X 3 times here, then we have X 4 times here. But each time you transform X, you select that specific transformation, you transform it again, right? So here we have this X, and then X, an array inside. Then we have the same thing here, but then we transform that transformation, and then we do that again. So the same thing goes here. You select the number or the nested array. Now you can see nested array. But if you have another nested array, you're going to nest this nested array inside of that. That's 2 levels deep. You could go to any depth that you want. So now that you have this, what you can do is you can just select that, put it right here, and put it right here. Both places where you have the any type. And in this scenario, this is going to work perfectly fine for you. We do have a problem here, and this problem is basically the current type is number, but it says type nested array is not assignable type number. Type this is not assignable type number. It says, okay, here we're talking about the nested array type. Here we're talking about the number type. How can stack accept a number and a nested array? So in this scenario, we can just typecast this. So for this one, I'm going to create a new array here. So I'm going to say const, I could call it current array. And I'm going to select. Now, if I'm inside of the if statement, that means what? That means our current item is a nested array. So I'm going to say current as nested number array. Let's pass in the array. And let's select this, copy that. We're going to say current array dot length. And finally, we need to put it here. So that's for the if statement. Here I'm just going to say as a number. I'm going to cast the type because it's a little bit difficult for TypeScript to understand what it is that I'm doing. Very good. Let me just comment this one out. Let's select our current. So the type of this is already nested number, and in here the type of this is, we say, okay, the type of this is, I know why this happens. So you could keep this, but since the type is already that, I'm just going to get rid of it. I know why it says current is the type of it is nested number array, because if we go inside of this if statement, it means that this is array is true, and this is array is true only if current is equal to an array. That's why here we say, okay, the type of this, we cast it as a number. Because if we are inside of the else clause, it's no longer an array, it's an item, right? Like this one is no longer an array, it's an item. 6 is an item, it's not an array. So let's save this. Let's actually run this to see if there are any problems that we need to solve. So I'm gonna run this first. Very good. A note. Okay. So we have our input 1, 2, 3, 1 level to 10. There we go. Everything is perfect. And this is going to be it for the TypeScript solution. We did talk about a lot of things, especially this recursive types that I've not covered in these challenges before. So that's a very good and new and interesting addition to it. Aside from that, I hope you really learned a lot from this manual way of going about things, because we need to go to our Python solution, which is going to be one of the easier ways to actually going with this, the solution of this challenge. And for Python, the main method that we're going to use in order to flatten an array, the main one is going to be the extend method. So first off, let's go ahead and let's create our function that's going to be flatten array. We already know that this accepts an argument. And what is this going to do? The first thing that it'll do is create a new list for us. Arrays are called lists in Python. This result is going to contain the flattened version of the input that this function receives. Now, this solution is going to be a combination of the TypeScript one and the JavaScript one, in which we're going to use a for loop as though we want to go manual, but then we're going to use some built-in methods. So we want to take a look at every individual item that exists within our input array. And to do that, I need to first just bring everything here. So these are our inputs. It's easier this way if I just talk about it. So we want to select any element inside of our input, and then we want to take a look at that. If there are only two cases. That could be an element, like a primitive type, or that could be an array. So we're looking for an array in here. Now, if it is primitive type, like it is a number type, we just add it directly to result. We just append it directly. But if it is an array or a list, we want to flatten it and then add the items there. So the first thing that I'm going to do is I'm going to say if element, for every element inside of the input array, I want to do the following. I want to check if that element is an instance of a list. So this is instance is a built-in function that checks if an object is an instance of a class. List is going to be our class that we're looking for, and if that element is an array, what do we want to do with it? Well, we want to flatten it and then store the items inside of the result. In other words, we want to unpack the array items. So for that, we can use the extend method. So what the extend method does is it's going to grab all the items from a specific array or a specific list, and it's going to get rid of the array syntax. And it's going to add those to wherever we say add it. So, but the key thing here is that we need to call this recursively. As I explained how recursion works, it works in the same way here as well. And I'm going to explain that as well. So we have to call our function flatten array recursively here. And I'm going to come back to this, why this is a major point, why this is important. And if we go to the else class, what condition is going to hold true? How can we go to the else class? The else class is only going to hold true if that item is not a list. That's a primitive type. So if it is a primitive type, we can simply use the append method. And that brings me to the point why are we using extend as opposed to append? Because append also adds items to a list. And finally, what we need to do is we need to return something from this function. So let me just complete the solution. Return result. Now, how does this actually work? If we take a look at our extend versus append, both of them add items to an array. But the append method adds the item as it is. So if you had, for example, for your append, let me just write it above it. So for the append, if you pass in something like this, 1 and 2 and 3. So if you want to append an array to another array, append does it. So it's going to just simply add the same thing to that result. So what this will give us is going to be result that looks like this. So it's an empty array, right? And then append adds the same thing. Let me just copy it and put it right here. Now, if we were to use append, we are going to end up with nested arrays again. That's not what we want. We want to get rid of the nested arrays. We want to flatten the array. And you can see clearly we're not flattening anything. So this is how append works. But how does extend work? When it comes to extend, let me just use the same example. If we take a look at our extend, and just this name has to be extend. If you pass in something like this to extend, so you have passed an array to extend. Extend is going to get rid of the array syntax, so it's going to unpack it. And what this will give us is going to be something like this. So it's going to give us this. It's going to get rid of the array syntax, and it's just going to add 1, 2, and 3. Now, why do we still have the array syntax? That's because result itself is actually an array. So these square brackets, they belong to the result itself. They are not coming from the extend. So in this scenario, it's very easy to see that extend is when we want to unpack nested arrays, and we can use append just to append simple elements like 1 and 2 and 3 primitive types. But if it is of type object like this, it's better if we just use extend. So how does this work recursively? In the first, we know that this is a for loop, so we check every element inside of the array. In the first iteration, we come across 1. Okay, so if I talk about 1, does this condition hold true? No, because 1 is not a list. We go to the else block. Cool. Inside of the else block, we just say grab this result and append to it that specific element. What is that? That's 1. So now result has 1 inside of it. What is the next element? Now keep in mind, this array actually has 3 elements. The other elements, they are nested, right? So we have this element, and then we have this one, and then we have this one. So in the second iteration, we select this. Once we select this, does it go here or does it go here? Well, it goes inside of the if, right? Because this is a list. And once it goes inside of the if clause, what happens? We grab the result, we extend the result by adding that element in there. But we call the function, right? And the function is going to execute this entire thing again. So if you pass in this thing to extend, what is extend going to give you? Extend is going to give you a flattened version of it. So let me just copy this entire thing. So if you pass that in here, what is extend going to give you? Extend is going to give you this, whatever is inside of there. There we go. So it's going to give you whatever is inside of there. But it's not going to add 3 and 4 and 5. It's just going to add, it's going to come back to this 2, right? Now, let me just explain it like this. So once you pass an extend is going to give you something like this. Let me get rid of the result. But then you call the flatten array again. And once you call the flatten array again, you check this again. You see that this is a primitive type. So it goes inside of this else clause, therefore inside of the result. And then you end up with the same thing again. And extend, once extend flattens this thing, extend is going to get 3 and 4. It's going to put it inside of the result. And in the next iteration, you're going to have 5, which is going to go inside of the else clause into this append. And finally, you have 6 in the last iteration, which is going to go inside of the append. And effectively, result is going to be 1, 2, 3, 4, 5, and 6. And the same goes for all of these, even if it is like 10 levels deep. Now that that's over, we can just go ahead and run this. So for this one, I'm going to say, let's just cd there, Python C tab, enter, and there we go. So we have, let me just take a look at our solutions. We should have 1, 2, 3. There we go. We got 1, 2, 3 from here, and this is 1, 2, 3. We have 1, 2, 6. We have 1, which is right here. We have 1 to 10. There we go. An empty array, and then again 1, 2, and 3. That's very cool, right? So this is it for the solution to Python. Let's move on and let's talk about the next language, which is Go. And the solution for Go is going to look a lot like the solution that we did for Python. It's very simple in Go to implement this. Let's first off import our main package. I'm going to create a function and I'm going to call it flatten array. What this function is going to accept is going to be an array. Now, what we need to pass in here is the any type for an array. And unfortunately, the way we created a recursive type in TypeScript, we cannot create a recursive type directly in Go. So what we can do is we can say that this array could have a type of any, which is the modern syntax for instead of using an interface. So interface is like the older syntax, but from Go version 1.18, we use the any type in order to signify that the int or that the variable has or the data could have any type. Now, this any type could be, now the unfortunate thing with this one is it could be strings and it could be any other primitive type or any other complex type. For example, lists or objects. So we need to filter this out, right? But this also specifies or takes into consideration if we have one level nested array or two or whatever. Now, what we return from this function is going to be a list or an array that is going to be of type integer. Now, let's go ahead and let's create our function. I'm going to create our result slice or list or array using short variable declaration, and the type of this is going to be integer. Initially, this is going to be empty, but we are going to populate this. So let's iterate over our input array. This iteration is going to give us index, which I'm going to ignore using this blank identifier, and it's going to give us the element itself. We're going to use this element in order to determine if it is a number or if it is an array or another slice. So let's use our range, and here we have the array. So how do we determine this? If I'm going to go exactly like Python. So I'm going to say if the nested slice is equal to, how do we know if an element is actually a slice? We can just say element, and we need to take a look at the type of that, right? And the type of that is any. Now, if it is of this type, we need to return OK from this as well, because we need to have our true or false. If this is true, then what do we want to do? We want to create a new variable, and I'm going to call that flattened. And in here, we're going to call our function recursively. And once we call the function recursively, if the item is of type integer, it's not going to result in the recursive call of this function. But if the item is only of type slice, now unfortunately the type of the slice could be of type string or whatever, but we are going to fix that. If the type of the item is slice, it's going to recall this function, but once it does that, it flattens the array as well, right? So we are going to unpack the array items, and then we're going to call the function, and during that call, we're going to unpack the array items as well. And once the function is called again, this flatten array, since we have unpacked the items, we're not going to go inside of the if statement or the if clause. We're going to go inside of the else if, which is going to determine to add those individual items to our result, exactly like the Python version. So here, let me just fix or complete this one first. I am calling flatten array. And then what am I going to pass in here? I'm going to pass my nested slice, because that is a slice on which, or that is a slice with which I'm recursively calling my function. Now, we need to go ahead and unpack this after we have called the function, because in no way we want this if statement to add items to our result. Because if statement adds items to our result, that is going to be basically another list or another slice, and we don't want that. We want to flatten the list. We don't want to make it deeper and deeper. Therefore, in here, I'm just going to grab my result, and I'm going to say append. We're going to append to the result a flattened version of that nested slice. And that those three dots, we have already talked about them, right? They are the unpacking operator in Go. And that's the F part, which is going to recursively call this function itself again. But if we go to the else if, that means that the item is of type primitive. But then we need to determine if that type is of type integer. So we need this OK in order to actually find out if it is true or false. And using short variable declaration, I can say if element is of type integer, then I want it to be added directly to my results array. So I'm going to grab results, and I'm going to pass in that specific number. Now, at this point inside of the else if, I am sure that it is a number. Cool. So far, I think everything is okay. And finally, what we need to do is we need to return something from this function. Return result. And now that we have created our function, it's time for us to actually take a look at our test cases. So we have this test case. The problem with Go is that if I select just this array, put it right here, comment it out. The problem with this is that this array has how many arrays inside of it? So it has one wrapper array, one array nested there, that's 2, and another one there, that's 3. So aside from the primitive types, you need to type annotate the slices that are inside of this big slice. So you need to type annotate the array and the nested arrays as well. And they look like this. So you could say you need to put it outside. So I'm going to get rid of the square brackets, right? and we need to pass in the array itself in there. So I'm going to select this. I'm going to round it. I'm going to wrap it with curly braces. I'm going to say any, and there we go. So that's the type annotation for the outer array. And then you need to do this for the inner arrays as well. So for this array, you're going to have to repeat any 3 times. But what if you have an array that has 10 arrays inside of it, like this one? Then you have to repeat any 10 times, right? This is what the problem with this is, that it's going to get verbose too quickly. What I can do is I can reduce from the density of so many words. We could create a helper function that's going to allow us to do this easier. But the helper function has to be very, very flexible, because it has to know that it can accept as many arguments as possible, but the type of those arguments could be any, since that's what the function accepts as well. So I'm going to say this function toSlice is going to accept items, which is another slice. It's going to convert it to, it accepts a slice, it converts it to a slice of any, but the items within that slice could have any number. So there could be 10 items. These 3 dots, they specify unlimited number of arguments. And then the type of those could be any. What this function will return is going to be a slice of type any. Very good. And finally, what we return from this is going to be items. Go ahead and let me just copy paste our main function. I don't want to type all of this out. Now you can see this is the problem. So in our first input, you had 3 slices. Therefore, you need to call this function 3 times. The easier thing with this one is you just don't have to write another pair of. So if you say these parentheses are like square brackets for any, you don't have to write the curly braces. But still, it is verbose, and you have this. See? So you have arrays that are 10 levels nested, and then you have to call this toSlice 10 different times. Now, let me just save this and let's run it. Go run the tab, enter. We need to wait a few seconds for this one. You bring it up, and there we go. Very good. So we have 1, 2, 3, 4, 5, 6, 1, 2, 3, 1, and then 1 to 10, empty array, and 1, 2, 3. And there we go. That is it for the Go solution. Next up, the final solution is going to is the one in which we talk about Rust. And getting started with the Rust solution is going to look like some of the other languages, especially the Go language and the TypeScript language that we have done the solution for so far. But as we move along the solution, it's going to look more and more Rust specific. There are going to be a lot of things, I don't want to name them just now. There are going to be a lot of features that are just Rust specific and that we need to actually include inside of this challenges solution, that we have already talked about some of them throughout this second part of the series, which is challenges 11 to 20. But I don't want to overcomplicate anything, so let's just get started with the solution for this challenge in Rust. The first thing I'm going to do is I'm going to define our function, the function that actually does the flattening for us. And I'm going to go ahead and I'm going to explain everything. I'm going to make sure that I explain everything in detail so you really understand what is going on here. This function accepts an array. The type of array could be an array that has one item inside of it. Now, we're talking about arrays of numbers. So the array item has to be of type integer if it is just one thing. But if it is a nested array, then that's a different type. If it is a nested array inside a nested array, that's going to be a different type. So when it comes to Rust, what you need to keep in mind is whenever Rust is trying to compile your code, aka when Rust creates some sort of an executable that we have been running so far, like up until this challenge, Rust gives us an executable, we run that, and then that executable basically prints our result and shows our result for us. Now, in order to do that, Rust has to know exactly what the types of the data are that this accepts, that Rust accepts. It has to know that. Every single one of them. We saw something like this in Go, so I could just go ahead, even though it was just like we just talked about it. But you can see Go has to know exactly what the type of everything is. But we don't want to actually go ahead and create an ugly syntax like this. So if you have 10 arrays, you need to do all of this, right? An array that has 10 nested arrays inside of it. Now, what I'm going to try to do is actually come up with this syntax exactly like the one for JavaScript. So we have this test, which has the most nested arrays inside. And I want to be able to pass this exact thing to Rust, even though Rust is low level and it has to know the types. I want to pass this only. I don't want to say, okay, then to vector. Like in Go, we have slices. In JavaScript, we have arrays. In Python, we have lists. All of them are the same thing. So in Rust, I'm going to say to vector this and then to vector this. No. I don't want to do that. But I want to show you how Rust handles this, because in Rust, we actually have recursive types. So what I can do is I can borrow this idea from TypeScript, create a recursive type, and then that recursive type is going to call itself for any number of nested levels that it has. So if an array has 10 nested levels, the recursive type is going to call itself 10 different times. And each time it's going to talk about one nested level. And how do we do that? Well, for any type, much like TypeScript, we need to define a name. And the way we create lists or arrays in Rust is using the vec keyword. So vec or vector is the same as arrays in JavaScript. And I'm going to call this nested array. I'm going to keep the name as array, so it's really simple to understand. But what this function produces, nonetheless, it doesn't matter what it accepts. What it produces is going to be a vector of type i32. Now, you need to decide the range of numbers. For i32, it's -2 billion to -2 billion to +2 billion. And this is what this 32-bit integer is going to accept as the size for numbers. And I believe that's enough for our current implementation. Now, what is this nested array? So before going forward with the solution, with the actual syntax of the function, we need to create this recursive type. And I'm going to use enums in order to create it. And enum is, it's actually an enumeration, and it's like a choice type or a variant type. Now, you write the enum keyword, and then you write the name of that enum. So we have already named this enum. It's nested array. You could call it whatever you want as long as both of the names are the same thing. Now, what do we want this enum to do? Well, we are trying to grab some ideas from TypeScript, right? So what did we do in TypeScript? In TypeScript, we had two different associations for this recursive type. One was number, and number was to talk about individual items within the original array, within the parent array. And then we had a recursion of that, which was of type array, in order to talk about nested arrays. So in any scenario, we just have two different things inside of our parent array. We either have an integer or we have a list. We don't have anything else. So that gives us a very good clue of how many types we need to add inside of our enum. And what do I mean? So you can see the first item is actually an individual number. It's a literal number 1. The second item is a list. It's a vector. The third item is just a number. So at any point, we just have two things. Therefore, our enum could accept only two things. And these things are called variants for our enum. You could call them arms as well, but I like to call them variants because that sounds just so much better. So the first variant is going to be responsible for converting our numbers into an i32-bit integer. because that's what the function produces too. You need to decide one type, i3264, and then you need to stick with that until the solution is done. So whenever we call this integer variant of our recursive type, it's going to take a look at individual numbers. It's not going to handle lists for us. It's not going to handle arrays. This just handles individual numbers. So we need one type for our lists as well. So this list, I'm going to call this list. And what is a type annotation for a vector inside of Rust? This is the type annotation. And since this is a recursive type, it is going to call itself recursively. And I talked about this recursive process in Go language. It's the same thing here. Recursion has the same ideology behind it. It's the same thing, but the applications of that is different. So if you understand the idea, the concept behind recursion, calling itself several times in order to target all of the data, all of the use cases, then you understand no matter where the application lies. So that's it. So we have just two different variants for our nested array. It could be an integer, it could be a number. How do we know which one it is? We don't know. We just write cases for both of them within our flatten array function. Now, the first thing that I want to do before writing these cases is create our results vector. This is going to be a new vector, the items of which are going to be i32. Now keep in mind, this is our output. The output has to have the same type as the return type of the function. So i32, i32. What I mean is, this has to be the same as this, because both of them are the return type of the function. Now, we want to create a new vector. So on this vector, what we have is we have associations. Now in JavaScript, if you call a data structure like array and then or object and you do the dot operator, you're going to get the methods for that specific data structure. But in Rust, you don't have methods, you have associations, which are the same thing. The syntax is different. Again, the syntax is different. The idea is the same. So once you understand the idea, everything is going to click. Now, for this result, we're going to actually add items to this incrementally. So if we do that, that means this result is empty now, then it's going to get full. So this process makes this mutable or changeable. Mutable basically means something that's changed, that can be changed, or that will be changed. And in Rust, you need to specify that. So this mud keyword specifies that our results vector is going to change over time. Now, we need to come back to our cases. And for that, we need to specify some parts of this solution for Rust. We could use some built-in methods, but then we need to do some manual stuff as well. We want to iterate, so let's just keep it simple. We have an input array, which is one big array, inside of which we have 3 items. One of the items is a nested array that has another array inside of it. The other 2 items, number 1 and number 6, are simple items. So we just have 2 cases, and we just happen to have 2 variants for our recursive type as well. But these 2 cases can only work if we iterate over individual items of the array. And how do we do that? Well, we could use just a for loop, right? We're going to say element. Now, element is going to talk about one item of the array in one iteration at one time. And once it's done with that, we're going to go to the next iteration. Then we talk about the next item inside of the array. So for element in what? In array, in our input array, we want to take a look at 2 cases. So if you're familiar with the switch statement inside of JavaScript, we have almost the same thing in Go. The syntax is the same, but the syntax is different, but the idea is the same. So instead of switch, we have match. So we want to match this element. If element is a number, aka integer, we just put it inside of the result. But if it is a list, we flatten it, then we put it inside of the result. Because at the end of the day, our result must include only numbers, no lists. It must include the flattened version of the input that we gave to our function. And how do we call our variants of our recursive type in here? Now, why do we even need to call these? Because these determine exactly what the type of the items for our input array is. So if I call integer variant on this enum, what does that say? It says I'm looking for a number. And there we go. I have a number here. And then the second item inside of this input, it's a list. That means I'm going to take a look at this list because this list is the same thing. Now, the idea behind this is these two provide very good cases for us. One case holds true when we talk about number. The other case holds true when we talk about lists. So we could use them for our cases as well to just make sure we filter out the items properly. Now, the way you use these is you just call the name of the enum or enumeration and then the associative method on it. You have the integer, right? We called it integer. And then integer has parentheses, right? So you can think of this is a function that accepts an argument. The argument has to have a type of i32. So when that's i32, is that number 1, number 2, 3, 4? I don't know. I need to provide a general variable that is going to hold whatever that number is. I'm just going to call it num. You could call it number 1, number 2, but you don't want to hard code it. So this variable num holds the value of 1 in the first iteration. So it holds this value. But then it's going to convert it to an i32-bit as well. So an integer 32-bit. Now, once it does that, what do we want to do with that next? Well, this is one number. Let's just put it inside of the result. Why? Because 1 is the very first step that we want to flatten, right? So the flattened array is going to be 1, 2, 3, 4, 5, 6. So let's start with 1. And how do we do that? Well, we could just use the simple push method, which is going to push items to the end of the array or to the end of the vector. Very good. So now that this is done, this is our very first case. This was the easier case. That's when we iterate, we hit a number. Now, what if we iterate and we hit another list? And that's the second scenario. So in the first scenario, we hit a number. In the second iteration, we hit this list. This is where we use a recursion for the function itself as well, because we want to unwrap or unpack this item as well. So if I pass this directly to my result and then pass 6, what is going to be the difference between the input and the result, which is the output? Nothing. I'm basically copy pasting items into my result. I shouldn't do that. When I hit a list, inside of my list, I need to unpack that or get rid of the array syntax and then put all the items individually inside of my result. How do we do that? Well, we have a method which is called list. This is an association on our enum. So let's call our enum. On the enum, I have list. So as soon as I do L, you can see it's there. And then you need to provide a name for this one as well. I'm just going to call it nested. So nested refers to a nested array. I could call this nested array as well. It's lowercase nested ARR, just not to confuse it with the nested array, which is the name of the enum. Now, once I hit this nested array, I'm going to try to flatten that, right? And how do I flatten that? Well, I call the flatten array and I pass this nested array inside of it. And this is going to recursively, at this point, line number 16 is going to call the function again, right? So once it calls the function again, it sees that we have number 2, and then we have 3, 4 inside of parentheses, and then we have number 5. I'm going to explain how this works. It's very simple. Let's first store this value inside of a variable. Let's call it flattened. So once in the first iteration, let's go step by step. Element is, we take a look at the different cases. In the first iteration, element is going to be number 1. So we say element has 2 different cases. If element is a number, we take a look at this case. So element is a number, right? It's not a list. In the first iteration, it's number 1. So we pass number 1 here. It basically passes this test, and then we push it to the result. So after the very first iteration, result has 1 member, and that is number 1. So this vector just has a length of 1. In the next iteration, we hit this list. So once we hit the list, this case doesn't hold true. It's gone. We talk about this case because we have hit a list right here. See, this is a list. Now, once this is a list, I'm going to call this flatten array, which is the actual function itself. So we call the function inside of the function. That makes it a recursive call. So what happens in that scenario? Well, what do we call the function with? Now keep in mind, once we get to line number 16, the first time that we get to line number 16, that indicates that we have called our function twice. The first time is once we passed the big input, right? 1, 2, 3, 4, 5, 6. The second time that we call flatten array function, we call it with this. It's this one right here. So this nested array is exactly the one that is in the middle. So what does this include? It includes 2, another nested array, and it includes 5. Okay, cool. So you call the function with this nested array, and the first item of the array is 2. Once you call the function, this loop runs again. So once this runs again, what do you think where 2 is going to fall into? It's going to fall in the same category that 1 fell into. It's going to fall into this category. So that's going to be what? That's going to be a push of number 2 to our result. So now our result has 2 members, number 1 and number 2. In the next iteration, we come to this part, right? We are now at the 3rd level, which is the most nested item, 3, 4. And then we get to this line again. So once we call this line a second time, that means our main function has been called a total of 3 times. So once we call this a second time, this 3, 4 is going to act as our input array. And what do we have the items inside of it? We have 3 and 4, 2 numbers. So in the first iteration of this for loop, we have number 3, which is going to pass this case since it's just a number, right? And then we put it inside of the result, and result is going to contain 1, 2, 3. In the other iteration, we have number 4. Number 4 passes this condition too, because it's just a number, it's not a list, right? And then we put that inside of the result as well. And in the next iteration, what do we have? We have number 5. In the next iteration, we have number 6. We put them subsequently in there as well. And that's it. This is how we get rid of the nested arrays. But this is not done without the use of the extend method. So the extend method is going to calculate total nested space in advance, and it's going to allocate it once. This extend method, this is actually the same method that we used in Python. It takes an integer and adds all items to the vector, and it just flattens that integer for that specific slice for us as well. So it gets rid of the brackets, it just adds the integers inside of the result. There we go. And what do I pass in here? I pass in here our flattened list or our flattened vector. Now that this is done, this was actually the easier part of this function. We need to return something from the function as well, and that's it. So the function is done, but the more important part, or the more difficult part, is yet to come. And that part is what I actually hinted at when at the very start of talking about the solution for Rust. And don't get me wrong, our solution is actually completed. The only thing else that we need to do is to decrease from the verbose syntax that we used inside of Rust. I'm going to give you an example. So if I call my main function, and if I try to pass this to my flatten array, it's not going to work because I did not type annotate 1, type annotate what this is, type annotate 6, type annotate the inside items. I need to type annotate all of them. And if I go ahead and type annotate all of them, it's going to look like something. It's going to look like this. Let me just give it to you. Whoops. Let me just paste it here. There we go. It's very, very cool, right? So if you have just 6 items with 2 arrays nested, this is how you are going to type annotate this. And how did we do this? We said 1, we called our recursive type, we called it with the integer variant, and we passed in 1. But then the second item is an array, therefore we called the nested array and we called this association, which is list. And then we call the vec macro again, and we pass in this into this nested array again for number 2. For number 3, 4, we call the list again, and then within the list we pass in 3 and 4 as integers. We go out of that list, we call 5, and then we call 6 as integers as well. And that's it. So you can see how horrific the syntax is. It's very difficult to read, even though we just have 6 items. Very simple. Just 6 items. Now imagine this. If I ask you to type annotate this one, this big array, 10 levels deep. What if you have an array that has 1,000 levels of nested arrays inside of it? What if it has 1 million levels? How are you going to do that? How are you going to do it then? Well, you need to come up with some way to do this programmatically. And Rust actually has a very specific feature that we have covered several times inside of our solutions before. So if I go to our sum of elements, which was challenge number 11, and if I come right here, we talked about this, macro rules. Now a macro is actually a way for us to create code programmatically. And what kind of code do we want? So this sum of elements, this is challenge number 11, which I've already taught like a couple of months ago, few months ago, and this is our challenge number 18. So what macro does is it allows us to not write all of these comments, but instead just pass the array as it is, much like JavaScript. But we need to programmatically tell it to do so. So what I'm going to do next is actually try to create our macro, but then we're going to have the most complicated macro so far. But since you already have some basics when it comes to macro, it's going to be very easy for you to understand how different parts go about. And I do want it to be a little bit more complex because I want you to get out of your comfort zone a little bit more, so you really understand and that part of like programming clicks for you too. So we're going to go ahead and we're going to get started with macro, but I'm going to explain it as though you don't have any prior knowledge of what a macro is and how and why do we even need a macro. So we need a macro in order to generate code for us at compile time. So a language like Rust, it has a compile time and it has a runtime. A compile time is when you select your file, Rust, and you convert it to an executable. The time it takes to do this, and this operation itself, it's called compile time. So if I go to my terminal, if I cd into 011, hit tab, enter, now I have items, I have access to my Rust code. If I do Rust C, E, tab, I have sum of elements. As soon as I hit enter, this is compile time. It took a couple of seconds, right? Compile time is over. Now I have an executable. We didn't have this file, right? So here I have this executable. Once I run this, that's runtime. I hope this is clear. So compile time converts it to an executable. Executable time is whenever you run that. Runtime is whenever you run the executable. And where is our code? Our code is inside of this executable. And how do we run it? Well, we just call that. It's very simple. We just say e-tab. So you need to make sure it is e hyphen sum of elements hyphen. The extension is very important, .exe. And let's hit enter. And there we go. This is what we did inside of challenge number 11, all of our test cases. So the problem with Rust is that as soon as it does the compile time, once it tries to create an executable, during that time, it needs to understand what the type of the items are. It needs to understand what this one is, what this middle thing is, what this last thing is. And then what are these things within this middle thing? It has to know all of that. Therefore, we need to write all of this. So it's your choice. Do you want to write all of this, or you want to create a macro that generates all of this? You just pass in a simple array to a macro, and macro during compile time is going to generate all of this. You're not going to see it, but it is there. Don't worry. It's there. And it's so efficient, so fast, that it is actually a good best practice to use macros instead of writing all of this, right? So that's why we need a macro. So we avoid all of this. And when it comes to macros, macros are very, very simple. I'm going to close this file. I'm going to keep this because I want to talk about this EXPR that we have talked about before, and just remind you of a couple of stuff that we have actually covered so far. And to get started with a macro, there are actually two things that we need to keep in mind. There is some code that I'm about to write that is part of the macro syntax. So it doesn't matter what kind of a macro you're going to create, you need to actually write the syntax for that macro. Like we have a syntax for a function, like the fn, the parentheses, the curly braces. These are part of the syntax. We have the same things for macro as well, syntax. But then there are some things that are custom, that are specifically tailored to our current challenge. And as I move along, I'm going to explain which parts are part of the syntax and which parts are some things or some code that we write custom. Now, the first thing that is part of the syntax is actually writing macro underscore rules. We have seen macros before throughout all of these 17 previous challenges, and I would like to show you some built-in macros as well. So if I come to my challenge, which is this sum of elements, which is challenge number 11, here, let's go down to our main function right here. So wherever you see some word and then in front of it, something that looks like a method, but in front of the name of the method, there is an exclamation mark, that is actually a macro. So whenever you see, okay, so this sum elements, this is something that we have created. It's from right here. That's our custom macro. But if I come here, there we go. So we have here this print, and this is a built-in macro. We have another built-in macro here. So the syntax, whenever you call a macro for a built-in one or a custom one, is the same thing. As you can see here, we have this built-in one. We have the name of the macro, the exclamation mark, and then parentheses to invoke that macro, to call it. But then if I come right here, the sum elements, that's our custom macro. And we have the same syntax. We have the name of the macro, which is custom. And then once we call the macro, we need to pass in that exclamation mark along with the parentheses. And the way this works is you need to create this macro rules, and it's going to be followed by this exclamation mark. That's part of the syntax. Right after that, you can provide the name of your macro. It could be whatever you want. I'm just going to write it array. and then we open up curly braces, which is the block for this specific macro. Now, going back to why we need this macro, so we can really understand how many rules are we going to create within this macro. I'm going to jump into our JavaScript solution, and I'm going to select all of these inputs, all of these test cases for our function, and I'm going to put it I could put it right above that input. Let's just put it right here. So we have these cases, but it's not limited to these. We could have more cases than these as well. So we could have an array that has 100 levels of nested arrays inside of it. But then if you can write a rule that covers this array, which is 10 levels nested, then you can write this, you can use the same rule for an array that is 100 times nested. All right, now moving forward. We need to have a rule that states that there are only items, there are only numbers within the main or parent array, like this one. So in this scenario, the main array doesn't have any array inside of it. It is just an array, and you just return that. But you need to check it out. You need to see if this is the case. We need to have another case for if we have just one item within the array. We also need to have a case or a rule for when we have one item, but that item is nested. So it could be 1 level nested or 100 levels nested, doesn't matter, as long as it's just one item. Because flattening this is just going to give us that same item. We have a rule, we must create a rule in order to understand however many levels of nested elements there are. We need to have a rule if we pass in an empty array here, and after this we're going to check all of these, and if there is anything incomplete we're going to add that rule as well. And since I am trying to actually teach you macro rules or creating custom macros as though you don't have any prior knowledge of it, I am going to start with the simplest macros, and then as we move along we're going to end up with more and more complex ones. So the first one that I want to talk about is when we don't have anything inside of our array, and that's an empty array. How are we going to handle this? So what do we need this macro to do for us? We want the macro to create code for us, to write code automatically. That code is going to type annotate this empty array for us. That's what we want to do. Now, once you write a rule in macro has two parts. First off, I'm just going to write this comment that is going to say rule 1 empty array. That's our rule 1. We want to keep this simple. Now, what I'm about to write here, that's part of the syntax for a rule inside of a macro. So inside of any rule, you just have two parts. You have the parentheses part, which is called the pattern, and then you have curly braces, which is called expansion. So based on some pattern that you pass inside of the parentheses, you're going to expand some code, which basically means you're going to write more code based on that pattern. What is that pattern? Well, we're talking about an empty array. There is no pattern, so it's empty. That's why the curly brace, the parentheses is going to stay empty. But for curly braces, what we need to do something. And what is it that we want to do? So if user passes an empty array to this app, to this program should generate an empty array, because at the end of the day, the challenges solution, our output, it is in the form of an array. It could contain flattened items, or it could contain nothing if the input was empty. And that's how we are going to go about this rule. So if there is no pattern, that means the array is empty. If the array is empty, I just want to generate an empty array. That's it. So I want to expand an empty array. And how do we create an empty array? Now, since we are inside of macros, we're going to use a built-in macro, vec. And this is going to create an empty vector for us. And that's it. That's the very first rule that we just created. And The way you separate macro rules is by semicolon. You need to add semicolon, and I'm going to go to the next line, and we're going to talk about the other rule. Now, the first rule just talks about empty arrays. The second rule is going to talk about single numbers. What if we just have one item inside of our array? Now, that item cannot be nested. It is just one item just thrown there inside of the array, and that's it. If in that scenario, what do we want to do? So first off, I need to write the name for this rule. This is going to be single literal number. The reason that I'm writing literal because it has to be literally a number. It can't be like 1 + 1 or an array of a nested number, like in this scenario. So what I'm talking about is this one. We want to create a rule for this one, but not for this one. Because this, even though there is just one item, it is nested. So let me just bring this up. This is our second rule. And again, if you want to create a rule for your macro, what do? You have the pattern part, and then you have the expansion part. And first off, we need to talk about our pattern. And for that, I'm just going to zoom this in. We want to talk about a single number. That's what we want to talk about in our second rule. And how do we define a single number? Here is where macro rules get a little bit more advanced. They get a little bit more progressed. So when it comes to that specific number, if you want to generate a new array based on that number, you need to store that number somewhere temporarily. That's how a macro rule is going to work for you. So here we just have this number 1, and we want to create an output that is an array inside of which we pass in this number 1. Now, this number 1 is inside of our input. How do we transfer it to our output? We just want to transfer it. We don't want to do anything else, right? Now, how do we transfer it? Well, we need to store it temporarily inside of a variable. And that variable is something that's called a meta variable. The name of the meta variable is up to you, but the meta variables in macros, they must be prefixed with a $sign. So if I write num is actually a meta variable. You could say number, but then you have to be consistent. If you said number, within the pattern, number must be used within the expansion too. But I'm just going to keep it simple, and I'm going to say num. This is our temporary meta variable that we use in order to store this value 1 inside of until we generate a new array or generate a new vector by this macro. And this term generation actually works for macro because macro automatically generates more code for us. Now, this number, I want this to be very specific. I want it to be literally this number. And for that reason, I'm going to pass in something that's called a fragment specifier. And this is literal. So literal is a fragment specifier that specifies we're looking for literal numbers, for literal values. We have already seen one other fragment specifier, and that was this expression. We have already talked about that. So in expressions, this is going to work for numbers, this is going to work for function calls, for whatever is an expression. But literal is just going to look at literal values, nothing else. You cannot pass in a function call into this rule and expect it to work. It's not going to work. So this is our pattern. We're just looking for one individual literal number. And if the pattern matches, what kind of a code do we want to expand? What kind of a code do we want to generate? Well, we want to generate a new vector, and based on that, and once we generated that new vector, once we created the new vector, we just want to pass whatever was inside of this num to that vector. Now, why don't we say just 1 instead of num? Because our array, which has just one item, that item could be 1, it could be 2, it could be 1000, it could be 99, whatever. We don't want to hard code this. So if I want to create a new vector, I'm just going to call the vec macro. And how do I create it? Well, I need to make sure that it is type annotated, right? And how do we make sure that? How do we make sure? We have this nested array type. And this nested array, it has a variant on it, which is called integer. And I'm just going to pass our num right in there. And that's it. We have created our second rule. And the second rule is just going to select one number, create a new vector, put that number inside of it. But during this process, it is going to convert that number to an I32 as well. Now, that was our second rule. Let's go ahead and let's talk about our third rule. So in the third rule, what I'm going to talk about is nested arrays. Because we have arrays like this one, which are 3 levels deep. We have arrays nested right here. We have 10 levels of nested, 9 levels of nested, but with the top level, it's 10 arrays of nested here. So that's going to be our third rule. But the third rule, I don't want it to be overly complicated. I just wanted to talk about nested arrays. If an item, if within an array we have an item, we don't talk about that. If within an array we have another array, then that array is nested, we talk about that. So this is just about nested arrays. And what do we want to do here? Here, what I'm going to do is I'm going to use another fragment specifier. So we have talked about expression, we have talked about literal. Here we're going to talk about token tree. And that's actually very, very simple for us to do. Now, let's talk about nested arrays. If an array is nested, I don't know at any given time and any given point in time how many levels that array is nested. The array could be nested 10 levels deep. It could be nested 1000 levels deep. It could be nested 100 levels deep. I have no idea. That depends on the input. But what I do know is I need to create a rule that regardless of the levels of depth, it has to work. So if the array is nested 2 levels, it has to work. If the array is nested 100 levels, it should work. That's what is that's what the idea behind this rule is. And since we wanna take a look at this nested array in a recursive manner, we need to create a rule that keeps this recursion in mind as well. So if an array is nested 10 times, it is nested once, and then that nested array is nested again, and then it's nested again. So it's the same thing that is being repeated again and again and again. And this pattern is called recursion. So whatever we do within this rule, we need to talk about recursion as well. So how do we create first? Let's come up with our pattern that handles that. And then we're going to talk about the expansion code that this macro is going to generate or it's going to create. So our pattern must match a nested array. Keep in mind, we are talking about an array. We're not talking about items of that array. We just talk about the array. If our array is 10 levels deep, our pattern must be repeated 10 times. Same goes for 100, same goes for 1000. So our pattern must be repeated. So we need to have some sort of a repetition pattern. And how do you write a repetition pattern? Well, for macro rules, you have a specific syntax for them. The specific syntax starts with a $sign and a pair of parentheses. This specific syntax means this is a repeating group, or this is a repetition pattern. It could be repeated again 10 times, 100 times, or 1000 times, but it is bound to be repeated. That's why we write it. Now, once this is repeated, we need to specify if there is a vector inside another vector, then we want to repeat this. So this pattern is always repeated inside of another vector. It can never be repeated outside of the vector because nested levels, they go inside, they don't go outside. So for that specific reason, I'm going to surround this with square brackets. That is going to basically define that this pattern is inside of another array. And then it goes inside of the other one, and then the other one, and then the other one, until it finds the deepest level, which is the array nested. So this is our repetition pattern, and this is part of the syntax. Cool. What we want to create yet, that's part of whatever we want to write. Custom. That's our custom thing. So we want to repeat a pattern several times, depending on however many levels there are. You need to have something that holds the nested arrays, and you can call it whatever you want, but if it holds something, that's going to be a meta variable. So it starts with a $, and I could say inner. This is going to be the inner is always going to be the nested array that we are looking for. But then you need to have a fragment specifier here too. And why do we need a fragment specifier? Because we need to have some bounds. We need to have some rules based on which we are going to take a look at which value it is that we select. So once we passed a literal fragment specifier, even though we store the value inside of, we stored it inside of the num, we said, if it is literally a value, then you store it inside of a num. So fragment specifiers provide more information on how to use our meta variables. Now in here, we're going to use a TT, which is called a token tree fragment specifier. This is actually the most flexible fragment specifiers. It matches any type, any single type in Rust, or any single token in Rust. I should call it token since this is actually a token tree. So TT means token tree. So this is our fragment specifier. Why do we use this? Because this is the most flexible one. And what does this stand for? It stands for token tree. What is a token? In this specific scenario, a token is the smallest meaningful unit of code. So token could be 1, 2, 3. Token could be like X, Y, Z. It could be our operators like plus, minus, or it could be delimiters like the brackets that we're looking for in order to understand if there are nested levels. And generally what this means here is that this specific part is going to tell us, this part right here, what this tells us is that we are trying to capture 0 or more tokens, and we want to call each of them inner. And then, so we're not still done with our pattern, because the pattern has to look through something, and once the pattern hits a match, we're going to expand some code. And we need to add one more thing in here, and then our pattern is done. And that is something that actually completes our repetition syntax. And what do we need to add here? Let me just bring my cursor. So here we have, this is our repetition pattern. And outside of our repetition pattern, I'm just going to go ahead and I'm going to add the star. So if you add a star, this means match 0 or more times. If you add, what does that mean, 0 or more times? So you want to repeat your repetition pattern 0, at least 0, 1, 2, 3 or more. So if there is an array that doesn't have a nested array, this is not going to work for it. But if you pass in plus, that would mean match 1 or more times. If you pass in a question mark, this is going to basically mean match 0 or 1 time. So which one do we use? We could use the plus one. Let's just use the plus one. So now that our pattern is actually created, let's try to use it. So how do we use this pattern? This pattern is just for nested items, nested arrays. And if it finds a nested array, what do we want to do? Well, we want to make sure to call that recursively in order to get rid of the nested array and to unpack all of the items from it. So at the end of the day, we want to generate a vector. We already know how to type annotate that. This is, so macro uses our nested array, our recursive type, to type annotate the code that it generates. So which variant do we select? Since this only talks about lists, we're going to select a list, and we want to call our macro recursively. So whenever you want to call your custom macro, you're going to pass the name of the macro, which is ARR, and then you're going to pass in the exclamation mark, which specifies that this is in fact a macro. What do you pass to this macro? To this macro, you want to pass whatever you stored inside of your inner. You want to pass that in there. Now, how do you select the content from the inner? You just call inner, which is our meta variable. But then this inner, it could be repeated one time, or it could be repeated 1,000 times. You could have 10 levels of nested arrays. So for that specific reason, we need to have our repetition pattern here as well, which starts with a $sign. You have your parentheses, and then you say, repeat this. We added a plus. I'm just going to add a plus. Repeat this one or more times. That's our rule number 3. That was the most complex rule. That was the most complex one, and that's it. The next rule is going to be a combination of the couple of rules that we've created so far. And it is for, let me just write it here. We want to take a look at multiple comma separated items. Now, for each rule, I want to actually write what that rule is going to match. So this rule is going to match our very first rule. That is going to match an empty array for us. And I just want to write that here. So this is going to match array. Let me pass that in there. Okay, this is going to match this. And for the second rule, what is this going to match? Match an array that has just one item inside of it. That's what this is going to match. So that item could be whatever. I'm just giving you some examples. It could be 1. And then let me just copy this. It could be, I don't know, like 4 or 5 or whatever. Like, you get the point. That's what this is going to match. The third rule that we created matches this, the token tree one. So match, this is going to match. This is how we call the macro. That's why I'm passing that in there. So what this is going to match is going to be a nested array. This is, let me just copy this part. This is also going to match items within that nested array. We don't care if the nested array has items or not. We just care that it is a nested array. But if there are items, we're going to expand those items as well. And then you might have another nested array, and then you could have like number 25 in there. And now you actually get the point. This is what this rule is going to match. And for rule number 4, we want to match comma separated values. And these comma separated values could be simple items like 1, 2, 3, 4, 5, or they could be arrays, or they could be a combination of items and arrays. So for this rule number 3, so I need to bring this up. So rule number 3 is going to talk about this and talk about this. It's not going to talk about this one, rule number 3. Rule number 4 is going to talk about this. So the remainder, the last, I shouldn't say last, the next rule that we have, rule number 4, is going to talk about all of these. I could just copy their names, just copy rule number 1. I'm just going to put it right here. Just wait a second. Just bear with me. This is rule number 2. What that's going to match. This is rule number 3. And there we go. And then rule number 4 is going to match all of the following. This is going to be multiple comma separated, multiple comma separated values. Shouldn't just prolong it too long. And I'm just going to pass it there. There we go. So the rest of the items can be controlled by this rule number 4. There we go. So what is the pattern? Well, the pattern is that we could have let's take a look at one of these arrays. You can select any one of them. I could select this one. So let's bring that up. We could have a number at the start, or we could have an array at the start. Doesn't matter which one it is. And then we could have an array in the middle, and then we could have a number at the end, or it could be any other way that you can think of. But they are multiple comma separated values. If it is an item, we don't care. If it is an array, we don't care. We just want to make sure that our macro handles that case as well. So for this macro, what do we want? For this rule, what we want is actually to create the pattern first, and then talk about how the expansion is going to work. The expansion part is the easier part, as you have seen so far. It's just the pattern that's coming up, but the pattern is the most difficult part, because especially in these situations, and like rule number 4, where there is just a lot of flexibility, you need to have a pattern that actually talks about or covers that flexibility. So let's say our very first item is a number, or you could say the very first item is a list. So I need to have some sort of a meta variable that has the ability to store a number or a list. Cool. What am I going to call that? Well, I'm just going to call it first, but then this meta variable has to be able to store a number or another list. So this has to be very flexible. Which one is the flexible meta fragment specifier that we have used so far? TT, token tree. So I'm just going to pass in TT there. And this is going to specify that this first meta variable is going to act based on this TT fragment specifier, which allows it to store items like 1, 2, 3 and nested arrays or arrays. Now, this is one item. We could have next to this another list, or the other items that we don't know what they are. But I know that there is more than one of these. That's why I added comma after TT. So the rest of the items could be whatever you want. It could be another list. It could be 10 more lists. It could be 100 more items. I don't know. I just know that I have one thing and then several other things. And the other things, I'm just going to call them rest. But then what is going to be my fragment specifier based on which this is going to work? Well, we need to have the meta variable syntax correct. And then you see this $, that's the repetition syntax. Because if this first, let's take a look at our very first example. So this first, this one, this is going to talk about 1. And then after 1, we have one item, and then we have 2 items. So we have 2 items. Okay. We have 2 in this case, but what about this case? In this case, we have one item and then we have another item. So that just happens to be 2 items as well. We have 3 items, sorry. So we have this item and then we have this one and then we have this one. So depending on the array, after the very first item, you could have 2 items, you could have 100 items. So that's why we need to have this repetition syntax. If I just write it with this rest without the repetition syntax, that would mean that we're talking about only 2 comma separated values, the first and the rest. These 2 comma separated values could be both numbers. They could be one number and one list, or they could be 2 lists. But this rule would only work if you just have 2. But what if we have 3? What if we have 100 items inside of the array? Well, then we use our repetition syntax. And let's just add the comma, and I'm going to pass in plus, which is going to specify we're going to repeat this 1 or more times. And finally, we want to make sure that after each of these items, there is actually a comma in there. And for that, I'm going to grab my repetition syntax and I'm going to pass in a comma, but we don't want to have 1 or more commas. we want to have either 1 comma or no comma at all. So for that, we're going to use this flag, which is the question mark, for our repetition syntax. And that's it. We just completed our pattern. And based on this pattern, we need to come up with how the expansion is going to look like. And coming up with the expansion for this, it's going to be a little bit different than how we did it for the previous rules. The first thing that I'm going to do is I'm going to open up a new pair of curly braces. And this second pair of curly braces is actually called an expression block. We use this in order to make sure that this rule can accept multiple statements. What do I mean by multiple statements? Take a look at this. So the expansion can only be created with an expression block because there are several statements nested inside of one another. So you have this nested array with integer, and then you have the list. Within the list, you have another integer. Within that list, you have another one, and then another integer. You can see several levels of nested. And that's why we need to have an expression block. And what do we do within this expression block? Well, within this expression block, we need to create our vector. That's very simple. Our vector is going to be the first item plus all the remaining items. That's how I'm going to go about this. So I'm going to say mut, which is going to be mutable. The first item, I'm just going to call it v. And why is this v? Because this could be changed. The first item could be whatever you want, depending on the input array. And then we want to call our macro recursively here. And why do we want to call our macro? Because this rule doesn't actually create anything new, any kind of new expansion. What this creates is it's going to call our rule 1, rule 2, or rule 3. So if you want to call any other rules within the same macro, you need to call the macro itself. And once you call something within its own body, that's recursion. So we want to call macro itself, and we want to pass this. So if there is just one item, that means we are going to talk about rule number 2. If that item is an empty array, then we are going to talk about rule number 1, which was an empty array. If that item is a nested element, then we're going to basically go to rule number 3. But the way that we switch among these rules is you need to call the macro itself. And what do you pass once you call the macro? Well, you need to pass that meta variable that you created, and that was called first. Now, we have created this. Let's move forward. What do we do next? So we need to take a look at the rest of the items as well. I did forget to add something here. We didn't provide the fragment specifier, since the rest of the items could also be of type item itself, like type of number, or another list. We want to have a flexible fragment specifier. That's why I'm going to pass in double T or token tree in there. Now, we want to select our whatever this v contains and add on to it the rest of the items. So I'm going to say v. Now let's say v is, in this specific situation, let me just go up. V is the number 1 for our input. Then I select that number 1 and I extend it. Now number 1 is not actually number 1, it's actually a vector. So I extend that vector with the rest of the items. But then those items have to pass the check too. Is that a nested element? Is that another item? Is that an empty array? What is that? So I need to call my macro again recursively in order to understand it, because I've created 3 rules above. This is the 4th one. And each of those rules is going to take a look at one of these cases that I just stated. And for that, I'm just going to pass in the rest of the items. Now, the rest of the items could be 1 item, 2 items, 3 items. It could be 1,000 items. So this syntax is bound to be repeated once or more, but it is going to contain some commas as well. So if you repeat it once and you want to repeat it, let's say 3 times, You repeat it once, you add the comma, that's the array syntax. You repeat it again, add the comma, and then you repeat it again, and then you add the comma as well. And finally, what do we want to return from this? Let me just terminate that line. What do we want to return? We want to return this vector. And that's it. So this is going to be our rule number 4. I am going to go ahead and I'm going to make sure that we call actually our macro and we come up with the main function so we can actually really see how this is going to work. So we have a few statements here. I'm just going to come right down here. I'm going to say if in main, this is going to be our main function. And where is our input? I'm going to cut these values because I just copied them. I copied them from JavaScript. And I want to show you that we can use the same syntax that we used in JavaScript in here as well. So this is my input. Let's create the output. You know what? I'm just going to copy paste it. This is the out. I'm going to copy paste these two as well. So we have our output. Let me just tab that. This is the output. It has to be let, not const. We have our flatten array. This is flatten underscore array. Let me copy this, come to here, just paste it here. Now we want, since the input contains all of the items here, we want to be able to copy that input's item and then pass it to our flatten. We need to call the clone method. Because if I just directly pass the items to the flatten array is going to take ownership of the items and it's going to consume all of the items. And then I will not have anything to show on this line. Therefore, I'm going to have this flatten array copy the items. So the original version is going to be passed here. Right? So like another, I would say like another copy of the items is going to be passed here. That's why I'm copying it. So if I don't use it inside of here, I'm not going to clone that. Clone is going to make a copy. And then we don't have these console logs. Instead of console log, we have a built-in macro, which is called print line. And whenever you have this print line macro, you need to add the exclamation mark. But then this output is not going to work like this. You need to have that debug specifier, like format specifier here as well. And that is going to be this for that output and this one for this one. Very good. What else do I need? I need to call the other ones as well. So let me just cut all of them. Come right here, paste them. Just tab this one step and then get rid of all of the console logs. We have print line, macro, and then where is our flatten array? Now here, I am passing an empty array, but then I'm not using the empty array again. Therefore, I'm not going to copy this empty array because I'm not using that again. And here, I'm just passing it there. I'm not using it anywhere else. And you can see it's just like the JavaScript one that we are transferring to here. The only thing remaining would be, let me just select this part to add our specifier. So the specifier is this, and just I'm going to add a comma there as well. We should be good to go. I'm going to zoom this out, close this file, and we had this. I'm going to cut this, just bring this up. Put it beneath this input. I want you to have that so you know what this macro is going to generate for us. Tab, save this. Let's go ahead, clear everything. We need to go to CD. What is the name of the file? What name of the directory? It's 018, right? 018, tab, enter, Rust C, E, tab, array rotation. This shouldn't be, I have copy pasted array rotation was the previous challenge. The name for these is actually incorrect. I just noticed that. It has to be flattened nested arrays. What I do is I just copy paste the previous folder and I just work into it on it. And honestly, I just copy pasted the previous folder. And in here you can see I've updated this, but I didn't update the name of the files. And I'm sorry for that. This is just going to take a second. This is, I don't really need that one. So let me just pass in B. I'm sure you noticed that right at the start of this challenge. This is flattened nested arrays. And then here we have E. There we go. And I'm going to get rid of this file because I don't upload this to GitHub. I don't just commit that. I copy paste the previous folder just to avoid creating these files. But then I remove all of the content anyway, so it's just easier if I create it and not embarrass myself like this. Anyway, I didn't see that. So I was like, why is this array rotation? We talked about that. I'm going to say Rust C E tab flatten nested arrays. I'm going to hit enter. We seem to have a lot of issues. We're going to go to the first one. The first one says macro rules note or missing fragment specifier. Oh, yeah. Yep. I have a few typos. Now, fragment specifier have double colon. So we need to pass that there. No, they have actually single colon. I'm thinking of associations. So they have single colon. And let's save this. I'm going to run this. That's going to take care of a few errors for us. Clear Rust C. Now let's see, what do we have here? I'm going to go to the top one. Array. Mismatched type. Expected integer, found integer. Flatten. So try using a conversion method to vector. Expected vec-nested array, found this one. Yeah, it is an empty array. Vec-nested array. That's going to be our second one. Arguments, this function were incorrect. Let me take a look at the next one. Flatten array to here. Nested array. Mismatched types. Flatten array 1. Expect int found integer. Argument to this function are incorrect. I think the problem is that we are directly calling our function inside of our main function, but where are we calling our macro? So we recursively called the macro here, but we didn't actually execute our macro. So we need to do that. Now, for that, I'm just going to select this function. And in front of the function, inside of the parentheses of the function, I'm going to call our macro. And then this macro is going to surround the entire. It's just going to be, yeah. This macro. Yep, I think that's correct, but we don't have it here. We don't have the macro itself there. We need to call the macro here. You need to pass these inputs to macro so macro can generate all of this. You need to pass the inputs. We didn't actually pass the input. So I'm calling the macro with this input. So with this one, and then I pass this, then I pass this, then this one, and the final one. And we should be good to go. believe so. Let me save this, clear this, run this again, input. Let me see now, what do we have? Missing token. First, didn't we add the token for the first one? Bring this down. Let's go to this. So it says first T. These are like just syntactical errors. First, this one. When calling this macro, let motivate array missing tokens in macro arguments. First array, even though we call the macro in there, and we added the tokens. I need to pause the video and actually try to understand what the problem here is, and then I'm going to come back. I think I found out what the problem with this is. It is saying, let's actually read through this. It's saying missing tokens in macro arguments. What does that mean? It says while trying to match comma, this comma that I added there, we hit an unexpected end of macro invocation. What does that mean? It means it was trying to look for this comma and it didn't find it in here. We don't have a comma in there. All right, that's okay. But then we said that we want to repeat our code one or more times. Now this rule number 4, what this does is it doesn't create a new pattern. It creates a new pattern, but it doesn't create a new expansion. It just calls the previous expansions into place. And if I take a look at the previous expansions or the previous rules, this rule, it was just for an empty array. That's okay. This one was for a single literal one. But this one says there has to be at least one item or more items. But even though I said this matches this one, but it doesn't match that because we have passed the plus in there. The plus flag says one or more times. We need to pass in star. The star says 0 or more times. And then that's going to cover the nested array inside an empty nested array inside like several other nested levels or just one level nested. But as long as this is actually a nested empty array. And you can see these two are different. So this empty array is nested, but this empty array is not nested. It's just our parent array, which is empty. Now let's go, I need to save this file. Let's go ahead and let's clear this. Let's call it again. Let's go to the top. Now you can see we don't have that error anymore because we covered the case if there are no elements within a nested array. If the nested array is empty. Now it's throwing something else. It says, this clone method cannot be called on this vec nested array due to unsatisfied traits. What this basically means is we don't have a specific attribute for our enum. When you create enums, you need to attribute them. You need to add attributes to those enums, and then you can basically pick and choose which features you want to give to your enum. Now, for this specific enum, we want to use it inside of our debugging, right? So what is debugging? Debugging is this syntax. If I go to the console, you can see it says you cannot clone this. You cannot clone the nested array recursive type. You cannot also use it for your debug specifier right here. So we need to make sure that our enum has two features. One is this debug, and the other one is the ability to clone stuff. And it's very easy to implement that. We have already done something like that. So it does have specific syntax. I'm going to do a pound sign and open up brackets, and we're going to call it the derive keyword. And this basically is going to be like, you can think of this like checkboxes on a form. So the more checkboxes you tick for like features, like when you have something delivered, you can choose a specific payment method. If you have 3 payment methods, you select one of them. If you have like 2 different delivery methods, or for example, one thing that I can really give you as an example is when you buy something on Amazon, it gives you the option when you want that thing or that item to be delivered, like on Monday, Tuesday, Wednesday. So you select one of those days. But then if you have several items, you could select different days for different items. You can think of this attribute as the same thing. You just give different features to your enum. What features do we need? We just need 2 features. We don't need to overcomplicate this. One is the debug ability, and the other one is the cloning ability. And that's it. Let's run this again. And now we just have one problem that says it is a warning actually. It has to be snake case. I used camel case, but it has to be snake case, this one right here. And let me get rid of the a underscore and then a nested ARR. Save this. Let's clear this. Let's run it again. And now during the compilation of this flatten nested arrays, this file gave us, this code gave us during the compilation all of the expansions that we needed from our macro rules. And we know that the expansions worked because now we have an executable. Unless they work, we're not going to have the executable. And now the only thing we need to do is just call this executable and make sure the extension is .exe. And there we go. Input is this, output. Let me just close the sidebar. Let's take a look at these. This is the first one. We have called the array directly on it, and it really clearly shows to you how this actually works, how you are going to call that. That's good. For the empty array, we have an empty array. For the one that has 1 inside of it, we just flatten it again. It's going to give us 1. If 1 is even 2 levels nested, it's still going to give us 1. If we have 1, 2, 3 in the parent array, we're going to end up with 1, 2, 3. I have changed the order of these. That's why they look different from the other languages' terminal output. So 1, 2, 3 comes from this 1, 2, 3, and this 1, 2, 3 is the same thing. We just have three arrays which we flatten, but then we end up with 1, 2, and 3. There we go. And then we have 1 to 10 there, and then 1 to 10 there. And this shows you what you needed to do before using the macro. So once you use the macro still is going to get rid of the other repetitive part for us, right? So this, you don't need to write the nested array and pass in the association. You just on the nested array, you just pass in the association. So 1 is integer. You can see macro does it automatically. You needed to write this by hand. Now macro does it automatically. And you can see how it works here. And it does it in the same way for all of the other ones as well. And I just wrote the rules. I could create 10 more arrays, 100 levels deep, and it is going to generate that for me very easily. So this was, now we are done with the solution for this challenge. And this was a really, really long video. I know that. And as I said previously, the idea behind these videos is nothing else than practicing programming. So, and I go on and I rant and I yap. I know that because I really care about programming. It has become like a really, really, I would say, unquenchable thirst of mine. That's why I'm creating these longer formatted videos. It's just, I want to spend more time programming. That's why these videos get longer. It's like I'm looking for excuses to talk more when it comes to understanding the code. And if you have the time to really watch these videos, I'm sure they're going to be worth your while. And with this video comes to an end, along with challenge number 18. See you in challenge number 19.